Okay, so again, here we have our two equations for consumer surplus and producer surplus. Number 6 here on page 476, we're given our consumer surplus problem. We're given our demand function P, where P is the price and X is the units. Demanded per month. Part A says find the number of mattresses demanded per month if the unit price is set at $400. First question, if the price is set at 400, because remember, for this consumer surplus, we need to know that little X bar. What's the quantity for that particular price? So part A is just stepping us through that. If the price is 400, what would the quantity demanded be? Well, this is a problem, first off, like the ones that you did in the last chapter. We have an exponential equation to solve. So we need to solve for x, so we first get the exponential by itself. So divide both sides by 600. We get 400 over 600, or if you prefer, you could write that as 2/3. E to the negative 0.04x. And now to get that stuff out of the exponent, we bring our good old buddy natural log into play and apply that to both sides. Of course, natural log of E will cancel out, and the other side will have natural log of 2/3. Natural log of 2/3 equals negative 0.04x. And we want to solve for x, so we can divide both sides by a negative 0.04. So we'll have natural log of 2/3 divided by negative 0.04. So that's the first part of the problem, is we need to find out when is it at that price. Okay. And now once we know that price, in part B, we're asked to use the results to find the surplus if the selling price is set at $400 per mattress. So in part B, we're told that P bar is 400. Of course, we know now that X bar is 10.14. And we want to find the consumer surplus. So we do the integral from 0 to that 10.14. And then our demand equation was 600 e to the negative 0.04x, and then minus our P bar. And at this point, you're more than welcome now to make use of that numerical function on your calculator. In fact, with this e to the x1 in the homework, you actually need to use that, because we haven't talked about something that we'd need to be able to do that integral of e to the negative 0.04x. On your test, I would probably stick with polynomials, but this just looked like a good example to look at. So using our numerical integral feature on our calculator, we can compute that, get 944.80. And then what is that 944.80? That 944.80, excuse me, that 944.80 is a surplus, but we got to remember that X was in units of 100, so the actual surplus is 94,080.